Very good morning, students. My name is Abhishek, and today in this video we are going to discuss the topic of quantitative aptitude, and the name of the topic is permutation and combination. So, students, permutation and combination is very important topic for all the competitive examinations. And as far as the complexity of this topic, permutation combination concern, so student get very confused in the topic, like what is permutation, what is combination, and where to apply the permutation, where to apply the combination, right? So in this video we are going to discuss each and every kind of problem in detail, and from the very basic concern, right? So let's start the video. So as students, the name of the topic is permutation and combination. So as the name depicts, this topic is made up of two things. The first thing is permutation and second thing is combination, right? So permutation simply means arrangement. Permutation simply means arrangement. And if I talk about combination, so combination simply means selection. So the topic made up of two things, permutation and combination. Permutation means arrangement and combinations means selection, right? Okay. Uh, thereafter the things that you must know before starting the topic, like whenever we have the condition of and, right, we have to multiply the things, and wherever we have the condition of or, we have to add the things, right? uh, Next thing is, whenever we have to apply a permutation, or I can say arrangement, we have to simply use the formula of arranging r thing out of n thing, that is npr, right? And for selecting r thing out of n thing, we can use the formula. The formula is of combination. The formula is of combination formula is ncr, right? So whenever we apply npr, the formula is factorial n divided by n minus r factorial. And whenever we have to apply combination, the formula is n factorial divided by n factorial, sorry, r factorial into n minus r factorial, right? So this is the very basic thing of the topic permutation and combination. Now next thing, we start that how next thing is, how many types of arrangements are there in permutation, right? So we study types of arrangement. So talking about type of arrangement, our first type of arrangement is objects based arrangement. Objects based arrangement means, if I say that you have to arrange a number of books on a table, or if I say you have to arrange a certain number of people in a line, or you have to arrange a certain number of balls in a basket, in a linear basket, right? So these are the objects. Second thing wherein we can apply arrangement is the letters, or we can say words, right? We can arrange the letters in words. Third thing, we can arrange digit in numbers. So we can apply this permutation in objects, words, and numbers. When talking about applying the arrangement in objects, so this can be categorized into two parts. First is linear objects, and the second one is circular object, right? Okay. In words arrangement, the only linear arrangement is possible. In numbers arrangement, only linear arrangement is possible. So students, let's start about the linear arrangement of object. Okay, when talking about linear arrangement of objects, so my first question is, there is a book, there is a table. On a table there are 10 books placed, right? On a table there are 10 books placed. Now my first question is, what will be the number of arrangement? What will be the number of arrangement? That means, in how many ways 10 books can be arranged on a table. So students, answer of this question will be simply factorial 10, right? Factorial 10. In factorial 10 ways 10 books can be arranged on a table. My second question is number of arrangement, such that two particular books always come together. Two particular books always come together. So students, for this question what you have to do, two particular books, so students, for this question what you have to do, you first have to arrange the two particular books. So two particular books can be arranged in factorial two ways. Now we are left with 8 books. Now you have to arrange this 8 books with the group of 2 books that we have already arranged. So how many things we have to arrange? We have to arrange 9 things, because 8 plus a group of 2, that is 9. So the number of ways will be factorial 2 multiplied by factorial 9. Okay. Third question can be number of arrangement, such that two particular books never together. Right, two particular books never come together. So students, for this question there is a formula, like two particular books never come together. There is a formula is total number of arrangement minus number of arrangement in which two particular books are together. So if we apply, total number of books are factorial 10 minus number of arrangement in which two particular books are together, so factorial 2 multiplied by factorial 9, right? So if we solve it, so we can take factorial 9 common here. So this will be 10 minus 2. So if we open it, we will get 8 multiplied by 9 factorial, right? So in this question we discussed three things: how to calculate number of arrangement, how to calculate number of arrangements such that two particular books together, number of arrangements such that two particular books never come together, right? Okay, let us take one more example for the better clarity. The next example that I would like to take, there are 10 software engineer and 7 civil engineer, right? There are 10 software engineer and 7 civil engineers, all have to arrange in a line. All have to arrange in a line. My first question is number of arrangement. That means question is, in how many ways I can arrange 10 software engineers and 7 civil engineers in a line, right? Second question is number of arrangement, such that all civil engineers come together, right? Third thing is number of arrangement, such that all civil engineers never come together, right? And fourth question that can be made here, number of arrangement, such that no any two civil engineers come together. No any two civil engineers come together. So students, if we look at the first thing, that number of arrangement, so number of arrangement will be simply without any condition, total number of things 17, and 17 things can be arranged in factorial 17 ways. Answer will be factorial 17. Coming to the next question, the question is number of arrangements such that all civil engineers come together. So, in this question, first thing that would have to arrange 7 civil engineers in a line. So, civil engineers can be arranged in factorial 7 ways. Now, we are left with 10 software engineers, and we have to arrange 10 software engineer with one group of civil engineer. That means 10 plus 1, that is 11. So answer of this question will be 7 factorial multiplied by 11 factorial. If we check for the third question is number of arrangements such that all civil engineers never together. So students, we have already discussed the formula of this question. This is total number of arrangement, that is factorial 7 minus number of arrangement in which all civil engineers come together. So students, this will be the answer, right? If we come to the last thing of this question, this is number of arrangement such that no any two civil engineers come together. No any two civil engineers come together. Students, listen. Third question and fourth question is different. In third question, the question is number of arrangement such that all civil engineers never together, and the fourth one is number of arrangement in which no any two civil engineers come together. So students, for this, listen the approach first. What I would have to do, I would have to arrange 10 software engineer first, right? We have to arrange 10 software engineer first, and 10 software engineer can be arranged in factorial 10 ways. This thing you know, right? Now I would have to find the number of places left where I can place 7 civil engineers. So students, if we check for the number of places left, 1 2 3 4 5 6 7 8 9 10 11. So students, the thing is we are left with 11 positions where I can place 7 civil engineers. So answer of this question will be 11p7, right? Students, always remember one thing: number of places left in a linear arrangement will be always one more than the number of objects, right? So we are given with 10 software engineers, so number of places left 11, 11p7, right? So for solving this question, we can write factorial 10 multiply by factorial 11 divide by 10 minus sorry 11 minus 7, that is 4 factorial. So you can find the answer is this format also or this format also, right? So students, I hope the question is clear. Let us come to the another example. Example number 3. Example number 3 of linear objects based arrangement. There is a table, right? Linear table, and I have to arrange 5 black balls and 5 red balls. Question is, I have to arrange 5 black balls, 5 red balls in a line. Now conditions are my first question is number of arrangement without any condition. My second question is number of arrangement such that all black ball always together, right? My third question is a number of arrangement such that all black ball never together, right? And my fourth question that can be made here is number of arrangement such that no two black ball come together, right? So students, the question is wherein we are given with two different objects of the same number, right? So first thing that you have to, and you have to identify number of arrangement without any condition. So number of arrangement can be simply total number of things and factorial total number of things. So answer of this will be factorial 10. Coming to the second question is number of arrangement such that all black ball always together. All black ball always together. So for this question, I would have to arrange all black ball first. So total number of black balls are 5. So we can arrange in factorial 5 ways. Now, next thing is we have to arrange this group of all black balls with 5 red balls. So 5 red balls plus one group of black balls. That means factorial 6, right? Coming to the question number 3, that is number of arrangements such that all black balls never together. So this is similar to the previous two questions that we have already discussed. This will be factorial 10 minus factorial 5 multiplied by factorial 6, right? Now, coming to the last question, this is a number of arrangement such that no two black balls come together. No two black balls come together. So student, for this question, what you do, you arrange first all red balls. So we are given with 5 red balls. 5 red balls can be arranged in factorial 5 ways. Now find the number of places wherein I can place 5 black balls. So in the previous question we have already discussed that number of places left will be one more than the number of object. So number of places will be 6. Number of places will be 6, and I can place 5 black balls on 6 places in 6p5 ways mein. 6p5, and when solving for this question, this will be factorial 5 multiplied by factorial 6 multiplied by 6 minus 5, that is 1 factorial. So answer of this question can be determined as factorial 5 multiplied by factorial 6. Right? So students, I guess this question is also clear. Okay, let me take you to another question wherein the question is something like the previous one that we have already discussed. There is a table, and on a table 5 black balls are there, 5 red balls are there, right? This in the previous question we have already done this thing, right? So we are given with 5 black balls and 5 red balls, and you have to tell number of arrangement uh, such that all black balls can be arranged alternatively. So students, when talking about permutation, alternative uh, arrangement is also an important thing. If we check about uh, arrangement alternatively, so what I will have to do this for this question. First, first thing, look at what is asked. Number of arrangement such that all black balls can be arranged alternatively, right? So students, there are two cases for this question. The first case is, first of all, you place all 5 red balls first, right? 5 red balls first. So my first case can be when I will place 5 black ball. So first black ball can be placed before red balls, like this, and second case can be, first of all, you place all 5 red balls and place first black ball after the red balls, right? So there are two cases. let us check the number of arrangement. If we arrange five red balls, so this can be arranged in factorial five ways. Now see, when I put first black ball before first red ball, so number of places wherein I can place five black ball are 1, 2, 3, 4, 5. Now in this case we will not have number of places one more than the number of object, because reason being we have to arrange alternatively, right? Because we have to arrange alternatively, the position that we are left with only B, 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 B. That means at only five places I can arrange five black balls. So number of places for placing a number of arrangement for arranging five black ball will be factorial 5. So if we solve this, we can get factorial 5 square. And coming to the next thing, here also first we will have to arrange five red balls, so this can be arranged in factorial 5 ways. Now in this case, I have put first black ball after the red balls. So number of places left will be 1, 2, 3, 4, 5. So at all five places I can put all black balls. So number of arrangement will be factorial 5 here. When solving this, so we can get factorial 5 whole square. Students, let us understand one more thing. Either we have case 1 or we have case 2. In permutation and combination, whenever we have the cases in or condition, student, we have already discussed that we have to add the things. So first thing we have factorial 5 square, and second thing we have factorial 5 square. So when adding this, we will get factorial 5 whole square, right? So students, answer of this question will be 2 multiplied by factorial 5 whole square. So students, that's all for the objects based linear arrangement. We have discussed approximately all the types of question. Rest, when we will be discussing the sheet, we will be discussing the more types of question. Now let us come to the second thing, that is circular arrangement. In circular arrangement, there is only one thing that is to be remember, that when arranging n objects in a circle, the total number of arrangement can be n minus 1 factorial. Uh, reason being, uh, reason being, first thing we have to fix, and I have to arrange remaining n minus 1 objects, right? So same thing if we apply in the questions. So my first question was in a table, on a table there were 10 books placed. Now I say that in example number 2, circular base, like in a circle there are 10 books placed. So my first question is same as the number of arrangement. So students, as we are arranging in a circle, so number of arrangement will be 10 minus 1 factorial, that is 9 factorial, right? Coming to the second question is number of arrangement in which two particular books are together. So student, for this, listen very carefully. First of all, I will have to arrange two particular books. So two particular books can be arranged in factorial two ways. This is same. Now we are left with 8 books, and I have to arrange 8 book plus this group of 2 books. That means 8 plus 1, that is 9. And for arranging 9 objects in a circle, this can be arranged in factorial 8 ways, right? Coming to the third question here. Third question is number of arrangements such that two particular books never together. This is same if we solve it. Factorial 9 minus factorial 2 multiplied by factorial 8. When solving for this, so we can take factorial 8 common here. We will be living with 9 minus 2. So we can get 7 multiplied by 8 factorial. right? So this was my first question in the form of linear and in the form of circular. Coming to the second question, 10 software engineers, 7 civil engineers. Now I have to arrange in a circular manner, right? First of all, the question is number of arrangement without any condition. So students, as we know that we are given with 17 objects. So 17 objects can be arranged in a circle in factorial 16 ways. Now, second thing, number of arrangement such that all civil engineers come together. So first of all, place all seven civil engineers at any places. So seven civil engineers can be placed in factorial 7 ways. Now I have to arrange this group of 7 civil engineers with 10 software engineers. That means 10 plus 1 group, that is 11. And 11 objects can be arranged in a circle in factorial 10 ways. So students, answer of this question will be factorial 7 multiplied by factorial 10. Coming to the third question that we are left with is number of arrangements such that all civil engineers never together. So student, this is similar to the previous one, that factorial 16 minus factorial 7 multiplied by factorial 10. If we check for the last question number 4 here, that is number of arrangement such that no any two civil engineers come together. No any two civil engineers come together. For this thing, student, first of all, uh, arrange all 10 software engineers in a circle. First of all, arrange all 10 software engineers in a circle. So students, all 10 software engineers can be arranged in factorial 9 ways, right? Now after this we will have to find the number of places left wherein I can place all 7 civil engineers. So student, we are given with 10 software engineers. We have arranged in factor 9 ways. Number of places left will be is equal to the number of objects. That means 10. And on 10 places I have to arrange 7 civil engineers. So answer of this question will be factorial 9 multiplied by 10p7. Right? Students, one thing I would have to segregate and I would have to enlighten in the concept, like when we are doing with linear arrangement, so number of places left will be one more than the number of object, and when we are doing with the circular arrangement, so number of places will be is equal to the number of object, right? Okay, so students, I guess the concept is clear. Coming to the next question here, the question is we are given with 5 black and 5 red balls. So 5 black, 5 red balls I have to arrange in a circle. So students, first question is number of arrangement without any condition. This will be very simpler, factorial 9. Coming to the second question, the question is number of arrangement such that all black ball always together. All black ball always together. So students, for this what I have to do, first I would have to arrange all black ball. So we are given with 5 black ball. 5 black ball can be arranged in factorial 5 ways. Now we have got a group of 5 black ball, and we have to arrange 5 red ball plus one group of 5 black ball. That means 5 plus 1, that is 6. And in how many ways I can arrange 6 objects in a circle? 6 minus 1, that is 5 factorial. So answer will be 5 factorial. Coming to the next thing is number of arrangement such that all black ball never together. So all black ball never together, total number of arrangement minus number of arrangement in which all black ball together, right? Okay. My last question is number of arrangement such that no two black ball come together. So for this, first of all, arrange all 5 red balls in circular manner. So this can be arranged in factorial 4 ways. Now find out the number of places left. So students, as we know that in circular manner, the number of places left will be number of is equal to the number of object. So number of places will be 5. So at 5 places I will have to arrange 5 red balls. So this will be 5p5. 5p5, and this can be written as factorial 4 multiplied by factorial 5, right? Factorial 4 multiplied by factorial 5. Okay. Uh, Thereafter, we are left with the last thing of the lecture, today's lecture. We have to arrange 5 black ball and 5 red balls in a circle alternatively, right? Alternatively. Students, for this question, what I have to do, as we know that when we talk about a line, so there are two ends of a line. There is a starting point and there is an ending point. But when we talk about a circle, so there is no ending point or there is no starting point. That means first end of the circle is connected to the last end of the circle, right? So in this question, we cannot make two cases. There will be only one case. And what will be that case? We have to arrange alternatively. First of all, place all 5 red balls in a circle. So 5 red balls in a circle can be arranged in factorial 4 ways, because 5 minus 1, that is factorial 4, right? And now we are left with 5 places. And at 5 places, I have to arrange 5 black ball. So total number of arrangement will be 5p5. That means factorial 5. So students, answer of this question will be factorial 4 multiplied by factorial 5 in a circle. And there will be no two case, there will be only one case, right? So students, that's all for the today's lecture, where I have learned, where I have taught the arrangement, objects based arrangement, wherein we have discussed linear arrangement and circular arrangement, right? So, students, if you have any doubt in anything that we have discussed so far, so you can make me a call. You can discuss. You can put a comment, right? And later on we will be discussing other things of the topic permutation and combination, right? Thank you.